Hello, my name's Carl. In this video we're going to introduce ourselves to TypeScript. So we've come along to this TypeScript playground, and this is going to allow us to try different features and understand what they are. TypeScript adds a rich type system onto JavaScript. So let's understand what the primitive types are in JavaScript before we start to understand that rich TypeScript type system. We can see from the Mozilla docs that there aren't many types. The main ones are string, number, and boolean. There is a big int type that's making its way into browsers now, but there's no date. There's not a lot really in terms of types, and there's no way in JavaScript to define custom types as well. And that's where TypeScript comes into play. Let's hop back to the TypeScript playground and we'll try this out. So we're going to create a variable for today and we're going to use the date constructor. Let's find out what type that is using the type of operator. We'll log that out to the console. And if we run that and then open up DevTools, we'll see that that is an object. So no specific type for a date. What about a number? Well, let's create an age variable and set that to 12, and let's log that out to the console as well. And this time it's a number, so we have got a specific type for numbers. And the final one that we're going to try to do is a string. So we've got a name variable, we'll set that to Fred. Let's log the type out to the console and we'll find that's a string. So there are some types in JavaScript, but only a few. The main ones really are string, number, and boolean. We don't have specific date types. We don't have the ability to be able to specify custom types as well. And that's where TypeScript comes into play. How do we create types in TypeScript then? Well, let's go through an example. We use what's called type annotations. So let's create a score variable and we're going to give it a type annotation. And we do that using a colon and then the type that comes after it. And then we can set that to the value as normal. So if we hover over our score variable, we'll see that it has been given the number type. So if we change 7 to be a string 7, we get a compile error. And if we hover over the score variable, we can see the message that we're getting from the compiler. Now if we turn our attention to the right hand side, we can see that the type annotation doesn't exist in the transpiled JavaScript, and that's because type annotations don't exist in JavaScript. So the compiler just takes them out. So all the type checking is only done at compile time. It's not done at runtime. One of the disadvantages of type annotations is it's extra stuff to type and read. So we can actually remove the type annotation in this case and let TypeScript infer the type. In the constant case, it's going to say that it's going to always be 7, but if we change it to let, then the type becomes number. And of course, because it's let, we can change the value of that number. To further illustrate the point, let's paste in a function that's got type annotations for everything. We can see that the parameters, the return parameter are all typed. So we can remove the type for the return parameter, remove the type on that total variable, and we can still see if we hover over the bits and pieces that we've still got the types in place. TypeScript's been able to infer those types. So we've saved ourselves a little bit of extra typing. The code is arguably a little bit more readable as well by letting TypeScript infer the types. But it couldn't infer the types for the parameter values, if we remove those and hover over, we can see that we get the any type rather than the number type. The any type is a special TypeScript type that tells the TypeScript compiler not to check the type. So it literally it's what it says on the tin, it can be any type. Generally it's not a good thing, but sometimes we do need to use it if we're not sure what the data type is going to be. So maybe we're dealing with a third-party library, we're not sure what the types are. Sometimes we do need to use any. It's worth pointing out there is an unknown type in TypeScript, which is an alternative to any, which the TypeScript compiler will do type checking. So you can check that out in this blog post. We'll move on to arrays now, and we can define a type annotation for an array just by putting square brackets at the end of the type annotation. So if we have a numbers variable, we can declare that with the number type annotation and square brackets after it. So let's refactor our sum function to sum an array of numbers. So we give it the array number type annotation, and then we can iterate through the numbers using the array for each function, and we'll just increment the total by n, and we'll initialize the total to 0, change it to a let, and that is our sum function done. And if we hover over the bits and pieces, we'll see that it's strongly typed. So it's managed to infer the n variable, which is great. Let's give it a try by console logging out the sum of 1, 2, 3, which gives 6 as we expect. So far we've used the primitive types and our TypeScript type annotations. So how do we create custom types in TypeScript? One of the ways is to use what's called an interface. We define an interface using the interface keyword followed by the name of our type, and then in curly brackets we define all the properties and methods within that type. There are no implementation details in an interface. It's purely the shape of the type, the contract that the object must adhere to be that type. And then we can use that type in a type annotation just as we have before. But you can see we've got a compile error on Bob until we satisfy that type. So if we implement all the properties for a start, and then we implement the method, and eventually that compile error goes away. We can reference the properties within the method using this. Let's give this code a little try by logging the say hello method out from Bob to the console. We get hello Bob outputted to the console as we expect. Now what if we try the type of Bob? What do you think that's going to be? Well, we get object, and that just underlines that TypeScript types don't exist at runtime. They don't exist in JavaScript. They only exist in the TypeScript compiler. Let's look at another example now. We're going to have an interface for a score, and that score is going to hold a person's name and then the score that they've got, which is going to be a number. Then we're going to create a function to find out the highest score given an array of scores that's passed into it. And the first thing that we're going to do is say if there are no scores, then we're going to return undefined. But if there are some scores, we need to loop around those and find out what the biggest score is. So we're going to have a variable store the maximum score, and we're going to set that to the first item in the array. And then within our loop, we are simply going to check whether the current item is bigger than the maximum score, and if it is, then we can set the maximum score to the current item, and then we simply return the maximum score that we found. Let's give this a try by logging out the highest score from this array, and if we run it, we get Gemma's score of 10, but if we increase Fred's score, we now get Fred's score as being the highest. Let's do another example of using an interface, this time using a class. So we're going to create our interface first, and it's going to be an interface for a logger, and it's just going to have a method in there called log, which is going to have a message parameter for the thing to log, and it's not going to return anything. And then we're going to create a class, and the class is going to be called logger, and that's going to implement that iLogger interface. And we're just going to implement that log method, and it's simply going to output the message to the console. So let's give this a try. We'll create a new instance of a logger, and then we'll use that log method to output hello. We'll clear the console, we'll give it a try, and we get hello output as we expect. Now, just to highlight the strong typing, let's try and add another parameter to our implementation of the log method. You can see we get a compile error. So let's change that, and let's change the message to be a number. And again, we're getting a compile error. So the TypeScript compiler is catching these problems nice and early for us. What about if we try and reference a logx method that isn't there? And again, we're getting compile error. So we can see that TypeScript is protecting us as we're entering our code. We can have properties in interfaces that are optional. So let's have a look at an example. We're going to create a score interface again with the name of the person and the score, but this time the score is going to be optional, and we define an optional property just by putting a question mark just in front of the type annotation. We're going to create an increment score function, and we pass in the score, and we're going to just return that score being incremented. So we're returning the name, and then we're going to add 1 to the score. And you'll notice we get a compile error because the score can be undefined. So we're simply ORing that with 0. And the function compiles, and that will work fine, but we can tidy it up a little bit by destructuring the score. So we're going to destructure the name and the score within that object, and we can default the score to 0. So this is going to tidy it up a lot. We can remove those score references, and we can also remove that or 0 as well. So that's tidied it up quite a bit. We'll give it a try by logging out an example to the console, and if we clear the console and run that, we see that Bob's score has been incremented by 1. Let's remove Bob's score now, clear the console, give that a try, and we can see that Bob's score is 1. just as we expect. Now it's worth pointing out that it's not only properties that can be optional, methods can be optional as well. So this is an optional method that we're adding to the score interface, and we're not getting any compile errors because it is optional. As soon as we move that question mark and make it required, we get a compile error. And parameters within methods and functions can be optional as well, again just by putting a question mark before that type annotation. There are other ways to define custom types in TypeScript. In fact, we can define the shape of the object, the contract for an object in line. Let's do that for our score example. So we're going to remove the reference to that interface, and we're just going to list out the properties that we expect the type to have. So we're going to expect it to have the same name and that optional score, and everything will still compile. We can try and use this approach for variables as well, and it works exactly the same. And you can see if we add another property to that, we get a compile error until we add that new age property. And this approach is nice if we're only using a type in one place, but obviously if we are going to reuse the type in many places, then we're going to want to use something like an interface. An alternative to an interface is a type alias, and we specify type aliases with the type keyword, and then the name of the type, and then an equals sign, and then we can specify the type. So we've replaced our score interface with a score type alias, and we can see everything is compiling okay. Once we get rid of that age property, the variable is okay as well. Some people prefer type aliases because it's a few less characters to type. In the past, interfaces have been more powerful than type aliases, but that's not really true anymore. They are pretty equal now in terms of the features that they offer. My advice is just to be consistent. So whichever method you choose to implement custom types, then be consistent in using that method. Being consistent will make your code base a little bit more readable. We're going to look at a slightly more advanced type now, and that's a union type, which is a combination of existing types really. So let's create a grade variable and let that be a union type of string literals, and more specifically A, B, C. So if we try and set that grade to something other than those literals, then we get a compile error. But if we set it to something that's valid, then obviously everything compiles okay. And we can use a type alias if we want to reuse the type. So we can create a grade type and set that to the union, and then we can just use the grade type for our variable. A union type can be made up of any types. So let's have a person type. Let's quickly do that, and then a company type. And then we're going to have a logit function, and the parameter in is going to be a union of the company and the person. And this allows us to pass in either a company or a person to this function. So we're going to branch off in the code. So first of all, we're going to deal with the person. So we check in there whether they've got a first name property. And if so, we're going to log their first name to the console. And notice that IntelliSense only gave us that first name property. And the second branch, we're going to log the company name. And notice the IntelliSense, again, has only given us the company name property. TypeScript has managed to narrow the types down. In that first branch, it's person. In the second branch, it's company, even though what was passed in was a union of them both. We're starting to understand the power of TypeScript now. Let's take it to the next level with generics. And generics is a way of passing types, varying types, into functions and classes. So let's have a look at an example with a class. We are going to pass a type into a list class of type T. We're going to have an add method, and its parameter is going to be of type T. We need some storage for our items, so let's add a property of type array of T. and we'll initialize that to an empty array. And then we're just going to push the item to that item's property. And let's not forget to reference this to get access to our items. We're going to have a getNth method now, passing in n as the parameter. The return type is going to be t, and we're just going to access and return the nth item. We're going to wrap up this introduction to TypeScript. First thing to remember is that the types are only available at pile time, so look on that right hand side, there's no sign of any type annotations. We've seen how TypeScript protects us, it's catching problems as we type. That's the big benefit of TypeScript. But it also helps our editor to provide refactoring features to navigate the code base. We do have to add type annotations, so there's a little bit of extra work, but we do get big benefits, and we can let TypeScript infer types as well, so we're not always having to type annotate our code. Hope you enjoyed this video. Thanks for watching.